Hello, I'm Ruben and today I'm discussing the fixed wing hacking drone dissertation. First looking at the carbon fibre drone itself, as CAD design was done, to which the CAD design was placed into a CNC machine. The CNC machine created the patterns. The patterns were then used to create the mould, and the mould themselves were used to create the carbon fibre parts of the drone. And as assembled together, here we have the actual fixed wing drone itself. All in all, the drone itself weighs 5 kilograms and it has a flight duration of 2 hours and potentially to 3. Now we can discuss the electronic components that have gone into the actual fixed wing drone itself. Components are motors to batteries, a compass, and receivers and transceivers. The main component which is holding all of these together is a Pixhawk. Pixhawk is like a motherboard in which you can place an SD card in with a certain type of firmware. So the type of firmware which was chosen for this is obviously a fixed wing, to which you can relay information back to the computer. Now on the computer side we're using software known as Mission Planner. Mission Planner allows you to plan out initial routes, switch the fixed wing drone into autonomous mode or even manual mode. Using 433 MHz receiver from the computer itself. With the explanation of the fixed wing drone, now we can have a look at the footage of the actual fixed wing drone being tested out. That's pretty good.
Just centre of gravity, you think?
I was having trouble circling there to do the airspeed calibration, so that's vital to tune it for map and knowing what it's cruising. It's a bit puffy down there. I would just land it. Yeah. I think something might have shifted inside.
It's coming down. Now to discuss the hacking side of the actual fixed wing drone. Raspberry Pi was implemented into the fixed wing drone itself. Inside the Raspberry Pi, Linux distribution was placed. So for the purpose of this, we're using Kali Linux, in which it has all sorts of cybersecurity tools, penetration testing tools. The Raspberry Pi itself, again, contains a 433 MHz receiver and a 2.4 GHz wireless dongle. To which this is powered by the actual Pixhawk, which is on board the fixed wing drone, supplying 5 volts. Now we're disconnected onto the fixed wing drone and the drone itself actually flying. The next part we can start discussing is the actual software used to communicate from the computer to the Raspberry Pi.
Okay, So now we can start reviewing the actual code implemented for the purpose of this dissertation. At first, it was decided to use C# to develop this code. However, further research showed that C# doesn't work very well with Raspberry Pis and network communication. So in this case, it was actually chosen to use Python. Python has a huge library, many modules, especially in network communications, graphical user interfaces, and it's easily tested as an interpreter programming language. So first, a graphical user interface was designed. Inside a graphical user interface, let's have a look at this code. You're given name of the term, the graphical user interface is wolf term, and then given resizing of the graphical user interface, we're using pixelated to add an image. Furthermore, we've got buttons, quit button, message boxes, tutorials, clear commands. Now queue edits, queue line edits are different types of objects which allow input of text. So you'll actually see quite a few of them. We've got one set up for messaging. We've got one which is the text scroll message box, which allows the receiving of messages sent and received, and other methods of log files being reviewed on there as well. So we've also set up text edits for IP addresses, port edits, passwords, and usernames. Now, now we can start reviewing the graphical user interface created for the remote desktop view. Again, it was done using PyUIC tool because you're taking a Qt designer design, converting it from the .ui file to .py. So again, we're using log start messaging with the twisted Python logs display. So we're using QScreen again, remote frame buffering, ready display, and this is actually linked. The client protocol, as you can see, is linked to the desktop client protocol as well. So we're using the draw maps, events, update to frame buffer, and we're actually taking the main inputs, event input sys of keyboard and mouse to this graphical user interface. So this graphical user interface will allow you to use the keyboard and the mouse. Furthermore, we're actually making sure that the password for the VNC is accepted from the input box. So actually, let's quick run of the graphical user interface so you can see what this looks like. So it's just a start and a stop button, and the main desktop when connected would show here. Now for this to work, we need to have a look at the desktop server protocol as well. So the server protocol side is twisted internet protocol again. So we've again imported defined messages, creation of packets, data received and data sent, any kinds of errors received. So we've got functionality, data received, parameters of self and data, a block of code in a try. Again, with the message defined with the keys authentication, handling from the message type, so define message.py. Again, password of client, the receiving end and the sending end. Frames, now this is quite important actually because we're starting to review a remote desktop view, so frame buffering is being reviewed as well, the handling side of it, and then again the password side. While we've already explained the protocol set, the grab screen set, now the functionalities of keyboard and mouse for both systems, which are Linux and Windows. So if we have a look at event input sys, here we are, we've imported import sys. Platforms, we said free because I was considering of implementing Mac, but there are various issues with it. So we have platform Linux using xlib, we have platform Win using ctypes import, and actually ctypes import is a Windows base C code. So that's been implemented into here. So for example, we've got hexadecimals which have been given, and it's equal to keyboard buttons and input. So there are various functionalities for that which have been mapped. So again, key mapping for the Linux system. Now mouse events, again press release from XY XY location, positioning, screen size, keyboard events using X11 as it's a Linux machine. Windows and mouse event is starting to become quite more simple actually, using Windows 32 API.mouse events from the imported library. Again, just giving the press release window and pass exactly the same done for Linux as well. With the idea in mind, we can start reviewing the receiver and transmitter serial protocol set. So if we go in here, we've set up variables for COM ports, names, broad, timeout, receive, callback. So in fact, this is all to do with the main component on a computer and a Raspberry Pi. That is the receiver and transmitter connecting via USB. So in fact, what this allows you to do is choose a COM port by saying COM port 1, COM port 2 with a baud rate of 9600, and you have to set that up on both sides of the computer, so the receiver side and also the sender side. So the main components of this code is whether the COM port is open or not, whether we've got any errors, receiving any connection, whether the COM port is closed to be able to check and actually realize if we're receiving callback. Furthermore, it sends out the messages and it's encoded in UTF, so it's human readable to the person. So just in case the messages or log files which are sent, it's not corrupt data. Now, if we go back to the main window here, we've actually implemented these methods into the buttons. So for example, we've got a button for replay log, replay thread, and then we've also got the open COM port. So the open COM port button allows you to put the COM port in and then reads it and allows you to, it tells you whether it's closed or it's open, stop replay log. Again, open file dialog. Now this is another step taken, so we've actually imported Tickinter here, a file dialog. So for a person to be able to take a file dialog, some kind of a .log file that they would like to send, you can send that using the file name, ask open file name, and select the type of file and send it. Now, the next part is the second part of this component was to be able to have remote desktop view. Now, for this to be able to be done, you have to have a client side and a server side. So let's start actually reviewing the code created for the client. So the client protocol, begin from the top. We're using Twisted Internet Protocol, a credible library which is able to define all sorts of sockets and data. What we're doing here is we're sending packets, so it's all to do with data receive, packet sending, handling, and key arguments. So what type of key arguments you're sending out, it needs to be able to handle these. So for the purpose of this code to work and to be able to handle message types, defining messages were created. So the defining messages of authentication were created. So, and then this was actually imported. That file was imported for it to be used as message types here. Furthermore, so the code actually lets you know whether authentication has failed or whether it has any type of issues. Server messages receiving, whether the messages are incorrect, any kind of problems with that. Again, password input as well. As we're working with remote desktop view, we have to be able to allow the code to handle pixel and data. So in this case, we've created another file called grabscreen.py. Inside grabscreen.py, we're working with PyQt5 again with QScreen. In actual fact, QPixMap is outdated now. So what this does is it takes pixelated data from a screen, and we use the grab window, and it takes the application desktop and a window ID, resizing and cropping to Grail, get pixel, get pixelation, and in this area we actually making sure that there's a comparison of both of them and calculated in which one is working better format. Now with the code explained, we can start reviewing what works and what doesn't work. Now, if we run the whole software developed, we can try sending buttons and commands, and it does not work. The reason for this is because of a queue reactor. Now, because we've implemented so many different types of methods to it, we have had to implement a method called a queue reactor, a different library in the Python library. And this allows you to thread or multi-thread various processes. However, these processes clash together and do not allow for the functions to work. Due to this lockdown mid the coronavirus, if I had the chance to be able to see my supervisor face to face or get some kind of help with this code, we would potentially have this working in no time. But this is my first time writing in Python code, and it was a big issue. However, a second component was added to this. Now this is called the server side, command prompt, and client side. Now in cybersecurity industry, it's well known that the terminal is used a lot. Now the server side is set up on a completely different system. So for example, the Raspberry Pi running Windows or Linux, and I can connect to that client using the terminal. So here I've got Python CMD client running the code to that certain IP address and the name of the computer or the Raspberry Pi with its ID as authentication. So if I press enter, client server trying to connect, and it connects, so you get command. So if I simply type in dir, you can see the directory that I'm actually inside the other component. If I run ipconfig, you'll be able to see its actual IP configuration. If I press net state, again, you can control all the methods on this. So there we have it, the full product demonstration. I'm sorry that the graphical user interface doesn't work properly at the moment. However, we definitely will be fixing the threading process. Sadly, due to this coronavirus lockdown, I've been able to be in contact full time with my supervisors to get more help towards the Python implementation. As the product became a lot bigger, it was a lot more difficult to be able to send and receive feedback in regards to tooling. However, I'm glad to still have the command prompt and terminal working, which still means that a person who's going to be using this out in the field will be able to gain some kind of communication to the Raspberry Pi or the system. I'd like to thank my supervisor Cliff for helping me with this project. It's been very difficult, but enjoyment. Thank you.